Alright, so this video is an introduction to linear combinations and span notation. Now, we're obviously talking about vectors, but this is going to apply to both Rn, vectors in Rn, and vectors in Cn as well. Now, technically Rn is in Cn, but we're going to be talking about things that apply to both of them. So a linear combination is basically, say we have two vectors, say v and w, in, let's call these together fn, okay, in fn, which means they're vectors, and let's say let's say a and b are the scalar of f. So if we have real vectors here, we'd have a real number here. And now what a linear combination means is if we have, it's something in the form of a v plus b w, and so v and w are set, they're defined vectors. However, a and b can be anything, so that's what a linear combination is. It's any combination of a and b with vectors v and w, but this of course extends towards multiple different, you can have many vectors with these different components. Now, a and b are just arbitrary scalar values for the field, so we could also define it as, say, there's a1, a2, and an vectors in a field, and say we have vectors, v is easy, v1, v2, I'm gonna underline it, that's my notation, v3 up to vn. It's inconsistent. I'll just add a3 to make it more consistent. Okay. Well then, a linear combination can be just v1 a1 plus a2 v2 plus a3 v3, that an vn, and you get the point. This is a linear combination of all these different things. I don't think an example is necessary for this, but this is a linear combination. So any one of these, like choosing any a and b, would be a linear combination of vectors v and w. Similarly here, this would be a linear combination of all these different v vectors, the vectors v. And now we have another notation that's called span. This is not a notation, this is a concept that follows from these linear combinations. Now a span of, I will use this analogy here, a span of the elements of the vectors v, v1, v2, v3 up to vn. So we'll say span, we're going to use a round bracket, curly bracket, and write v1, v2, since this is essentially a set, this part, so up to vn, cover. Now this essentially means we can have any scalar coefficient with these vectors. It's basically the linear combination of any scalar a values as a set. So essentially we have a1 v1 a2 v2. It's similarly to this, exactly the same actually, except we're gonna do set notation, and this span is basically equal to this over here, which is set notation such that a1 a2 to an is in the scalar field. So that's pretty much it. So the span is going to contain every single combination, and it's useful so that we can denote a large set of things. And that's it.